Hey guys, so this is an examples video about the exponent rules. This is a follow-up to my lesson video where I break down all the exponent rules, and now I'm just showing more examples and how to use them. So if you haven't watched my lesson video and you feel like this is a little too much, I highly recommend you go back and watch the lesson video. And also pause and try the examples as you feel that you need to. And I have free guided notes available on divideandconquermath.com. So this list of problems is actually all compiled in one PDF file. So if you want to just have that, you can totally go and download that for free. These are the 10 examples I'm going to go through. So I am really trying to be pretty thorough here in case you really want to see more examples. And just to break them out separately, because I know that's a lot to look at, here's the first 5. You can pause and look them over if you want. And then here's the last 5. So if there's a particular one that you want to see, you can just fast forward to it. I'm just going to jump right into it. Pause the video if you want to use it in a particular way, like to quiz yourself. So starting with this first one, so all I've got here is I've got the 5 first. So there's that number. And then I'm really just going to add up the rest of these exponents. So this is just using the product rule. So this is going to equal 5 x to the 5th, y to the 12th, and then just c. Okay, so B is an example of the power rule. So I've talked about this in detail in the lesson video, so you really need to kind of apply this exponent to each part. So the way that this is going to look, I've got 4 squared and then this x to the 7 times 2 and then y to the 3 times 2. So 4 squared is 16, and then this will be x to the 14th and y to the 6th. Okay, so now this one is an example of the quotient rule. So notice that the 5 and the 10, or sorry, the 15 and the 10 are both divisible by 5, so I can simplify this to 3 over 2. And now for the rest of these, I'm just going to subtract the exponents. So I'll take the x to the 7 minus 2, and then y to the 3 minus 1. So my final answer here is 3x to the 5th, y squared over 2. And like I said, if there's any of these that you want to practice first, do feel free to pause the video and make this what you need it to be. Okay, so for D here, so now we've got some numbers in front of the letters, and I've talked about this in the other video as well. So everything's being multiplied together. The word here is commutative. Multiplication is commutative. So that means that you can multiply in whatever order that you want. So I want to take these coefficients and I want to bring them out in front. So I want to look at this operation separately, and then I'm going to look across all the exponents and I'm going to add up the exponents together as needed, as I find the right base. So for the x's, I'm going to add up the 2 and the 7. For the y's, I'm going to add the 5 and the 1, and then I've just got the z to the 3rd, so that one has no other pair. Now, for multiplying fractions, I do have a video on how to multiply fractions if you need a refresher on that. You just multiply straight across. So this is 2 over 15, x to the 9th, y to the 6th, z to the 3rd. Okay, so now on to E. So this is another application of the product rule, and I talked about a similar example in my lesson video. So once again, we've got to apply this 3 on the outside to all the parts in here. Now for this fraction, I would recommend that you write it like this and just kind of deal with this separately. And then you know that you need to multiply. Sorry, you might hear my dog barking in the background. She's got to defend us against the mailman, you know. Okay, so let's see, this will be 2 times 3 and then z to the 3 times 3. Okay. So how do you evaluate this? So you just cube the top and the bottom. So 5 cubed, you might have to get out your fingers and toes here, but that's 125, and then 3 cubed is 27. And then this is x to the 9th, y to the 6th, z to the 9th. Okay, so now moving on to F and G here. So these are very similar examples, which is why I'm putting them next to one another. So notice really the only difference here is this exponent here. This throws a lot of people off, actually. So I wanted to compare them. So I highly recommend, since you see the negative here, and remember, this is all inside parentheses, you want to write this out as -3 squared, and then you've got x to the 5 times 2, so like this. this totally matters. I've talked about this in detail in other videos. So when you have this little thing squared, it's really, you're taking -3 times -3. So this whole thing ends up becoming positive, right? Because the negative times the negative is positive. So this is 9x to the 10th. Now, let's compare that to this example here. Same idea, where I want to write this out as -3 cubed and then x to the 5 times 3. So this is important to have this in the parentheses. So let's see now if I write this out, -3. So if I just think through this as a little thought exercise here. So this is going to end up being negative, right? Because you're multiplying 3 negatives together. So that's a really important distinction. And so then this ends up becoming -27x to the 15th. Now, in previous videos about exponents, I've already kind of discussed why this is different from this. I'll drop a link to that video if you want to review it. But this is like a very important thing just to kind of realize. And the reason that this will be in parentheses is because the original problem starts in parentheses. So hopefully that all makes sense. Okay, so moving on for h here. So now we're getting a little trickier. So we've got this whole thing. We're going to have to use kind of the order of operations in some ways to help us. So notice that I have this set of parentheses with an exponent. So this is actually where I have to start according to the order of operations. So I have to start with this set of parentheses and exponent. So in evaluating just this part here, let's see, I'll do it in pink. So this will be 2 squared, and then you're just going to multiply the rest of these exponents by 2. So let's see, and then we've still got the rest of this problem like this. Okay, so you have to first evaluate this part before you can worry about this part. That's actually according to the order of operations, so that's why we're kind of going through this. So 2 squared is 4, and then this is x to the 8th, y to the 4th, z to the, oops, I forgot to do the times 2, didn't I? This should be 6 times 2, so this should be z to the 12th. And then all of this times 3x squared z cubed. Okay, so now I can take the 4 times the 3, which is 12. And now I want to add the exponents. So I want to add the 8 and the 2. I don't have anything to match with the y, and then the z is going to be 12 plus 3. So there's what's going on in the background. So my final answer is 12x to the 10th, y to the 4th, z to the 15th. Okay, so for I here, so thinking about the same argument we were just making, right, about the order of operations. So once again, we're going to have to start really with this top piece because we've got the parentheses and the exponent. So if I start there, that will be x to the 6th, y to the 14th. So just multiplying each of those exponents by 2. And then I can take into account this bottom part here. So now I can see, oh, I can cancel out some x's and some y's. So I can now take x to the 6th minus 4 and y to the 14th minus 1. So this is x squared y to the 13th. Okay, so last but not least, here's this example. So this one looks a little bit tricky, right? So thinking about the order of operations, though, we still have to really deal with the exponent here and here. So let's just start with the top part. So let's see, I'll do this. I'll color code this in pink. And I'll do the bottom part in green, so we'll do them separately. So the top part, so I need to multiply both of those exponents by 3. So 4 times 3 is 12, and 7 times 3 is 21. So there's the top. And then the bottom, I have to multiply both of these by 2. So 2 times 2 is 4, and then this will be y squared. So here's where I'm at now. Now that I've done that, now I can use the quotient rule. So I can finish this by writing, this will be, I'll take the 12 minus 4, and then the 21 minus 2. So my final answer here is x to the 8th and y to the 19th, and that's it. So that covers it for all of those examples. I know there were quite a bit, but hopefully that was helpful. If you're looking for trickier examples or examples with just numbers, I totally have videos on those as well. So hopefully I'll catch you guys in another video. Thanks for watching.